Let's look at a few ideas from the light bulb lab that you did. You can see that I have a setup similar to the virtual lab, only using actual batteries, wires, and bulbs. So the first big idea was the idea of a circuit. A circuit is a closed continuous loop that electricity can flow through. So right now I have one of the wires unconnected from the end of the battery. On the other side I have a wire connected to the battery. It's going through the first light, connected to the next light, and connected here, and again this end isn't connected. If I connect it to the battery, you can see that the light bulbs light up. If I break it even a little bit, the light bulbs will go off. As soon as I'm connected, light bulbs are on. If it's unconnected, they go off. That's true no matter where the small break comes. So if I break the connection here, the circuit is no longer closed and the batteries no longer light. You may have noticed in the lab that it is possible to bypass part of the circuit. So if instead of connecting my wire over here, if I connect it over on this side, I can completely bypass this light bulb and electricity won't be flowing through it, so that light bulb won't turn on, and you can see that other light bulb is a lot brighter. So that's the idea of a circuit. The second idea that you're supposed to understand from this lab activity was the idea of charge flow. So the virtual lab did not have the ability to put a compass in, so I just explained compasses there. But here we can actually watch what happens to a compass. If I put a compass underneath a wire and then I close the circuit, watch what happens to the compass needle. Notice the compass needle points more to the right. This is what's really interesting is what happens if I switch the batteries around so that I have the positive side now over here on the left and the negative side of the battery over on the right. Again, watch the compass needle. Remember last time it deflected to the right. This time the compass needle deflects the opposite direction. The light bulbs still come on no matter what way the compass needle deflects. So what does this show us? This helps us understand that something is happening inside the wire. When the circuit is closed, the electricity is allowed to flow through the wire, and that flowing electricity is causing the compass needle to deflect. We know from our last unit that compasses are influenced by magnets, so this current is causing some kind of magnetic field which changes the compass direction. And we can definitely get a sense here that when we flipped our batteries around, the current was doing something different because it caused a different kind of deflection in the compass needle. So that's our second big idea, is that the wires are actually, there's something happening in there. You can think about it as charge flowing or current. Third big idea that the lab was supposed to help you understand was the concept of conductors and insulators. And it did that by having you explore a little bit more in detail a light bulb. So a conductor is any kind of material that lets the electricity flow through it, and an insulator would not let electricity flow through it. So on the virtual lab, you couldn't do much to investigate this, but here we can actually use our little circuit, simple circuit, to test out if something is a conductor or an insulator. So to do that, we need to take out one of our lights, and then that will allow us to have a test. So if the circuit is open, the light won't be on. If the circuit gets closed, then the light bulb will go on. So if I touch my two ends of my wires here to something that's a conductor, like the metal piece on here, then my light bulb should light up. If I conduct it to something that's an insulator, then the light bulb won't go on. So I can test all the different pieces of the light bulb with this. So the little black piece you probably just saw was an insulator. The tip of my light bulb is a conductor. We already saw the the screw part of my light bulb is a conductor, and then all the different wire parts of my light bulb are conductors as well. So what that helps us understand is that when I have a light bulb, it is part of a circuit. So there is a continuous path within a light bulb where the electricity has to be able to move through the light bulb. You probably have had a light bulb burn out before, and if you looked closely, what happens is this little wire in here, which is called the filament, if it breaks, which happens over time when it gets really hot, then the light bulb will burn out because this is no longer a closed circuit. So the final idea then, putting that all together, is simply that you can only get a light bulb to light up by having the two ends of the wire touch in very specific places. So for example, if I hold one part of my wire onto the end of the light bulb, and then I try and touch other parts of the light bulb, so for example, if I try and touch very carefully the little black area of the light bulb here, or the glass of the light bulb won't light up. But if I touch this just right, to the so one part of my wire on the end of the light bulb and one part on the side, I should be able to get my light bulb to light up. I'm having problems. I thought it was my light bulb, but there we go. So again, the pathway that the electricity is following, it's easier to see on here. The electricity comes in through the bottom, which is metal, and connects into one side of the light bulb, goes through the filament down to the other side of the light bulb, and then that part of the wire is connected in to the side of the light bulb. So hopefully that helps you understand what you were supposed to learn. As always, let me know if you have any questions.